So hello everyone, welcome back to Hasvora Education. Today we will be solving the Chemistry 9701 Paper 2 Variant 2 of the February-March 2025 session. So the time allowed for this paper is 1 hour and 15 minutes and the total marks for this paper are 60. So make sure you read off all the instructions before starting the paper. Let's begin with the question 1. So question number 1 says phosphorus and chlorine are the elements in the period 3 of the periodic table. Chlorine form three different compounds with phosphorus. The most common compounds are phosphorus trichloride and phosphorus pentachloride. Complete table 1.1. So in table 1.1 they are actually asking us the oxidation state of the phosphorus and the chlorine in each of the compound. So for chlorine you should know that it remains -1 no matter what happens. So this is just constant. For phosphorus in PCl3 and PCl5, what we can do is that we can simply first write the formula, and for this will be phosphorus we will leave it as blanks because we are going to be finding its oxidation state, and then we have plus NCl into 5 is equals to 0 because it's a neutral compound. So P plus -1 into 5, it will become P minus 5 is equals to 0 and P will be equal to plus 5. So this is for PCl5. I actually written PCl3 by mistake, so let's just remove this. This is PCl5. So in PCl5 the oxidation state of the phosphorus is plus 5. Now let's look for PCl3. It will be P plus -1 into 3. It will be P minus 3 is equals to 0 and P will be equal to plus 3. So it will be plus 3. Let's move on to the second part. It says in a closed system, the PCl3 and PCl5 exist in an equilibrium mixture as shown in reaction 1. So they have given you this reaction and the enthalpy change for this is in negative. So what you should remember from this is that in exothermic reactions, yield is favored at low temperature. This is the basic thing we have learned for the exothermic reactions. So reduce two conditions that favor the production of PCl5. So we have to give two of the factors that will increase the yield of this PCl5. So what can be the factors? You can clearly see that the PCl3 is in liquid form and the Cl is only in gaseous form. So 1 mole of the gas will be present at the reactant side and 0 mole will be present because the product is in the solid form. So what we can write is increase the pressure. This can be one of the point. The second point can be use lower temperature or lower temperature. These will be the 2 points for this second part. Now the third part says that the third compound of phosphorus and the chlorine, W, has a relative molecular mass Mr between that of the PCl3 and PCl5. Now this point is very important. I'll let you know why. The compound contains 69.6 by mass of the chlorine. So it is a compound of phosphorus and chlorine and it contains 69.6 by mass of chlorine, so the rest will be phosphorus. So first of all we will try to find the empirical formula. So if 69.6% is the chlorine, just subtract this from 100 to get the relative percentage by mass of phosphorus. It will be 30.4. This will be 30.4 divided by the AR, it will be 31 and here it will be 30.5. For Cl, the AR of Cl is 35.5 in case if you don't know, and the AR of phosphorus is 31. Okay, now let's just find the ratio. it will become 0.98 and this will be 1.99. So the ratio is about 1:2. So what we can get, the empirical formula will be about PCl2. Now the important thing here is that they have asked you about the molecular formula, not the empirical formula. And they have given you a hint about that it is between that of the PCl3 and the PCl5. So PCl3, let's calculate its mass. It will be 31 plus 35.5 into 3. So this will be about, let me just calculate this, 35.5 into 3 and then plus 31, it will be 137.5 137.5 grams. And for PCl5 it will be 31 plus 35.5 into 5. This will be 35.5 into 5 and plus 31, it will be 208.5. This will be 208.5 grams. Now if you find the MR of PCl2, which we have found actually, if we find MR of this, it will be 31 plus 35.5 into 2, or you can simply write 71. So it will be actually 102 grams. Now this do not lie between these two values. So what we can do is that we can simply multiply this empirical formula by 2, so we will get P2Cl4 and the MR of this will be 204 grams. Now this indeed lies between these two values of PCl3 and PCl5. So hence our answer will be, of the molecular formula will be P2Cl4. So this was quite a tricky question. Let's move on to another part. It says W is a liquid at room temperature and pressure. It reacts vigorously with water. So if it is a liquid at room temperature and pressure, it means it has simple molecular structure and it requires less energy to break the bonds. And it reacts vigorously, it means that it is hydrolyzing in the water because it has covalent bonds. And it is also forming an acidic solution. So suggest the structure and the bonding in W. Explain your answer. So W will have simple molecular structure as it has low, let me just remove this, it has low melting point and boiling point. That is why it is liquid at room temperature. And it has covalent bonding because it hydrolyzes upon addition in water. So this will be the answer. 2 marks for these 2 points, one for the bonding, one for the structure. Let's move on to the part B. Now in this part they have given you a reaction scheme in which the phosphorus, it is first reacting to reaction 2. Let's just first take this part. Let's just take this part first. So it is reacting with the chlorine to form the PCl5, and then that PCl5 is reacting with the unknown compound which is C, and then it is forming this halogenoalkane, or you can say this uh, dichloroethane. So what can we see? So if this is forming dichloroethane upon the addition of PCl5, it means that this compound C can be a alcohol. Why I'm saying this? So it can be an alcohol because in alcohol we know that the OH groups can be substituted in the nucleophilic substitution. So the OH group can be substituted to form a halogenoalkane as well. So the C can be an OH groups, a diol in a compound in which there are two OH groups. Now let's have a look at the other reaction scheme. So in which the phosphorus is reacting with the excess of oxygen. Now this point is very important because whenever they say excess of oxygen, this means that whatever the oxide it is going to form, it is going to be in its highest of oxidation state. So this gives you the clue, highest oxidation state. So we know that there are two oxides of the phosphorus. One is P4O6 and the other is P2O5, or you can also write P4O10. These two are actually the same thing, just multiplied by 2. So oxidation state do not matters. So the oxidation state for this will be phosphorus 4, and then we have minus 2 into 6, it will be minus 12 is equals to 0. So 4 divided by 12, it will be plus 3. And in this we have minus 10 divided by 2, it will be plus 5. So the oxygen state is higher in the P2O5. So it means that P2O5 or P4O10 will be formed because it is in excess of oxygen. So this solid will be P4O10. Now they are reacting this with the H2O, so it will dissolve to form the phosphoric acid. It will be H3PO4, and same if we react the PCl5 with the H2O, this will form PCl5 will, let me just remove this, it will the PCl5 will react with the H2O to form H3PO4 plus HCl. So this is actually the common product. It is written B is aqueous, so it will be H3PO4 for sure. So part 1 says suggest what is observed in the reaction 2. So this is the reaction 2. This one is the reaction 2 in which it is reacting with the chlorine. So what we will know is that the chlorine is green yellow in color, so it can disappear. The other thing that I actually believe should be true is that the PCl5, it is actually also a green yellow in color, but and it is a solid, so it can also be formed and observed. But here they have not given us the state in which it is formed, so it can vary. So I'll just suggest that move on with what you are sure. So Cl2 is gas and it has a green yellow gas. It is a green yellow gas. So what we can write is green yellow gas disappears. Then they have written predict the shape of the molecule of PCl5. So PCl5 have a structure like this. It has 5 valence electrons and this will form 5 bonds. So if you see, it is forming a pyramid structure, one on the top and one on the bottom. So it forms a pyramid structure, that is why it is called trigonal bipyramidal. And it is also actually forms a type of triangle. If you see here, it is in plane. The 3 bonds are in plane and the 2 are out of plane. So this is called trigonal gonal bipyramidal. So this is the shape of the molecule of PCl5. 3 says write an equation for the formation of A in the reaction 3. So reaction 3 is actually the phosphorus oxide. It will be P4, which is in the solid form, plus we will have the oxygen in the gaseous form. It will be 5 because the oxygen will be 10 if we form P4O10, and this will be solid as well. Name B, which is formed in both reaction 4 and 5. So I just told you that the common product of the PCl5 plus water and the oxide of phosphorus, the P4O10 and plus water, the common product between these two reactions will be the H3PO4. So they have given you that name B, so we cannot write the formula. It will be phosphoric. Let me just remove this. Okay, so it will be phosphoric, and the oxidation state is 5. phosphoric 5 acid. So this will be the answer. Okay, let's move on to 5. Draw the structure of C used in the reaction 6. So C was this compound which we predicted that it can be an alcohol. So we are just going to replace the points. So this was what was being formed, and this will be the C. OH can be here and OH can be here, so it will be replaced. So this will be the structure of C. This will be C. Let's move on. So C part says 1,2-dichloroethane reacts with NaOH to produce an unsaturated compound. So the hint they are giving us with the unsaturated compound word is that it is reacting with the NaOH. So what the NaOH is doing here, that it is eliminating one of the Cl here and forming a double bond. So what can you recall from this? That it can be an ethanolic NaOH, and we have studied this in the elimination reaction. So it is forming this unsaturated compound which is C2H3Cl as shown in reaction 7. So first of all they are asking what is meant by the term unsaturated. So this is a basic question. A compound in which there is carbon 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 double bond. State the conditions for the reaction 7. I just told you it can be ethanolic NaOH, so we will write ethanolic, dissolving the ethanolic NaOH. Also we have to heat it under reflux. So this will be the answer for this second part. Now part D says that compound D contains carbon, hydrogen and chlorine only. So this is the hint of the question. They have specified that it contains only carbon, hydrogen, chlorine. Figure 1.2 shows the mass spectrum of D. So they have given you this mass spectrum. Explain the relative abundance of peak 1 and 2 in the mass spectrum in figure 1.2. So if you look at the peak 1, it has a percentage abundance of 100%. It means that it will be molecular ion peak, or the peak of the compound when it has all the atoms, or you can say it has an isotope that is more abundant. So this is the molecular ion peak is always at the 100% abundance. Then at the second peak we can have a look that this one will be molecular ion plus 1 peak, and this second peak which they are talking about, this one, this will be the molecular ion plus 2 peak. And we know that molecular ion plus 2 peak only exists when there are halogen, the atoms of halogen in a compound. So we know that the chlorine is present in this. Let's just find the relative abundance of this. Let me just draw a line. Okay, so it will be here, it will be something about here, and this is the other one is for sure 100%. So let's just write the abundance. It will be 100, and this one seems to be about 33. Okay, so the percentage will be 3 is to 1. And for chlorine we know it has two isotopes, chlorine 35 and chlorine 37, of which the chlorine 35 has an abundance of 75% and the chlorine 37 has 25. So it also forms a ratio of 3 is to 1. So it means that the 100% will have the chlorine 35 and the molecular ion plus 2 will have the chlorine 37. So we will explain this as the ratio between peak 1 and 2 is 3 is to 1 due to different percentage abundance of two isotopes of chlorine, which are chlorine 37 and chlorine 35. Now, the last part says suggest the structure of D. So, how are we going to be reducing the structure of D? Is that first of all we can just apply the trial and error method. So let me just remove it from here so that I can do some working. Okay, so first of all what we are going to be doing is that we know that the molecular ion peak is at the 60. So this means the mass of the full molecule is 60 grams. So the MR of this molecule is 60 grams. Now we know that it will have the chlorine 35. So first of all we just take only one atom. So let's just deduce the mass left over after this. It will be 25 grams. So it means that we only have one Cl atom because we cannot accommodate another atom in the 25 grams. Now if you have a look here that we have a small fragment at the 24, it means that it is formed because of two carbon atoms. It is formed because of two carbon atoms because one carbon atom has a mass of 12. So let's just subtract this. We are left over with 1 gram. Now you can also see this is another fragment and this is at 25. So how can this be formed? This can be formed by HCH. So this will be because the 25 mass to electron ratio, this fragment will actually be formed because of the CH and a carbon atom. So now if you see that there is another fragment at the 59, this can be because of C, L, C and C. So the carbon associated with the chlorine and another carbon. So this will form the 59 fragment. So what we will know is that it has one hydrogen, one chlorine atom and two carbon atoms. Now let's just draw the structure, try to draw the structure. This is C, and here we will have the hydrogen at the other end and we can have a Cl, and now we have two bonds other to make. So we can clearly see it from the mass spectrum that there are no other bonds involved. So what we can do is that we will just make two bonds here. This means there are triple bond between the carbon. So this will be the structure of D. This is the structure of D. Let's move on. So question number 2 says the group 2 element shows metallic bonding. Define metallic bonding. So in metallic bonding what actually happens that the metal atoms lose their electrons and they delocalize to form a sea of electrons, and the metal atoms become the cations or the positive ions, and the electrons actually acts like a glue between the ions and the between the cations. So we can write it as metallic bonding is the metallic bonding is the electrostatic forces of attraction between cations and sea of delocalized electrons. So this is the definition of the metallic bonding that is acceptable. Part B says the group 2 elements show form stable 2 plus cations. State and explain the variation in ionic radius of the group 2 elements down the group. So down the group, what actually happens is first of all, the nuclear charge will increase. Why will it increase? Because the proton number increases. The other thing that will increase will be the shielding. So now these 2 points will actually counteract each other. The shielding will cancel out the effect of the nuclear charge. So, and the one other thing that will actually uh, be increasing will be the atomic size, because there will be more electrons, so more shell will be needed. So now this 1 point will actually increase the ionic radius. So we can write it as the ionic radius increases down the group as nuclear charge increases. So what does the nuclear charge do? It tries to shrink the you can say the atom, because of the you can say it is pulling, the nucleus is pulling the valence electrons towards itself. So as the nuclear charge increases, as well as the shielding increases. Now what the shielding does is that it just, you can say, tries to reduce the effect the valence electron experiences. It tries to reduce the nuclear charge that is being experienced by the valence electron. So the shielding also increases by the inner electrons, which counteracts each other. So these are actually cancelling out each other. But what other point could be that actually is resulting in the increase of ionic radius is that the atomic size increases as more electrons are, or actually as more shields, you can say, shells are required. As more shells, let me just remove this. Okay, so it will be as more shells are required to accommodate the increased number, or the increasing number of electrons. So this will be your 2 mark answer. Let's just move on. Second part says table 2.1 shows the successive ionization energy values for the beryllium Be. So beryllium is in the third group, so it means that there will be a huge surge between the second and the third ionization energy. Use table 2.1 to state and explain the general trend in these values and the significance of the large difference between second and the third ionization energy. So first of all, let's discuss this, that what will be the general trend. The general trend will be that the ionization energy increases generally, because as the electrons are being successively removed, what actually happens that the effective nuclear charge that is being experienced by the next valence electron will be greater and greater. So we can write this, that the successive ionization energy increases generally as the effective nuclear charge increased increases as each electron is removed. And the significance of the large difference will be there is large difference or surge between second and third ionization energy, which shows the shell change. Or you can also write that the next or electron is coming from an inner shell closer to the nucleus. So this will be your answer, one for the general trend and one for the difference. Now C part says that all the group 2 elements except beryllium have more than one stable isotopes. Beryllium exists as a single isotope which has a atomic number of 4 and it has a mass number of 9. So describe distribution of mass within the atom of beryllium. So we have just to write the you can say the mass, you can say that which one is more heavier and which one is more lighter in the terms of neutrons, protons and electrons. So what we can write is that the neutrons and protons which are combined to make 9, which are 9 in number, are heavier and centered in the nucleus, while the electrons are lighter and orbit around the nucleus in shells in orbitals. Okay, so this will be the answer. Complete table 2.2 to show the number of the protons and neutrons in the isotope of magnesium. So they have given you different isotopes. So the most common one which will you also form in the find in the periodic table will be magnesium 24 and 12. So this proton number remains the same. Let's just write the number of protons which will be the same, 12, 12 and 12. Now subtract this from the 24, 25 and 26. We will get the number of neutrons. It will be 12, this will be 13 and this will be 14. So this was a really easy question. So let's move on to part 3. It says the figure 2.1 shows the behavior of a beam of protons. So this is the beam of protons they have given us. This is the beam of protons. And complete table 2.1 to show the behavior of the separate beams of the neutrons and electrons in the same electric field. Label your diagram clearly. Assume the beams of each particle are moving in the same velocity. So what we will do here is that first of all, if the beam of proton is actually diverting in this direction, this means that this will be the negative plate and this one will be the positive plate. So it is actually repelling from the positive plate and attracted towards the negative plate. This means that how we can draw the, let me just remove this. Okay, so how we can draw the beam of the neutrons, it will be undiverted because it has no charge. So this will be how the beam of proton will look like. Let me just adjust it. So this will be the beam of protons. This is the beam of protons. And then we have the beam of electrons. Now remember, the electrons are much lighter in weight. So what will happen is that they will show a very sharp, you can say, turning. This will be a very sharp turn by the beam of the electrons. So this was your easy question for 3 marks. Let's move on to the D part. It says state what is observed when dilute hydrochloric acid is added to separate samples of the barium oxide and barium carbonate. So for the metal oxide, we have just studied that when they are added to the HCl, it forms a salt and water. So what will be observed? First of all, it will form the barium chloride. Now remember, it is soluble, and so what will actually we can write is that the barium oxide, which is white in color, the white solid of the barium oxide disappears because it is being dissolved, or you can say react with the HCl. And the barium carbonate, what will happen is that the carbonates reacts with the HCl to form the salt plus the water and CO2. So we can write effervescence of colorless gas, and white solid disappears because the carbonate is also white in color of the barium. So write an equation for the reaction of strontium with an excess of cold water. So strontium is in the group 2. This will be strontium solid plus H2O, which will be liquid, and this will form strontium 2 hydroxide. So this will be the formula for this, and as the solubility increases down the group, it will be aqueous in solution. So the equation is balanced. Yes, it is balanced. State the variation in the solubility of the group 2 sulfate down the group. So the solubility increases down the group. Also tell me, let me just tell you two more things, that solubility increases the reaction of the water, and the reaction of the oxygen of these metals increases down the group, like the reaction is more vigorous, or you can say violent. Also the sulfates, you can say uh, the sulfates actually their solubility decreases. So I have just done a mistake here. It is decreases, not increases. I just thought they were talking about the hydroxides. So the solubility decreases down the group. So solubility of the sulfates decreases down the group, the solubility of the hydroxide increases down the group, and the reaction of the oxygen and the water with these metals is more vigorous down the group, or more violent, you can say. So we have completed these two very large questions. Now we will have much smaller questions. So the halogen, chlorine, bromine, and iodine show a trend in the chemical and physical properties down the group. Table 3.1 shows some of properties of the chlorine, bromine, and iodine. So color and state at the room temperature. Chlorine is a green gas. For bromine, we know that it is brown liquid, brown and liquid as well. And for iodine, we know that it is black purple solid. It is black, or you can also say purple, black solid. Okay, so we have completed the table. It was just about the color and the state at the room temperature. The bond energies in table 3.1 refer to the halogen bond, where X is the halogen. Explain the trend in the bond strength of the halogen bond in the halogens. Okay, so if you see that the bond energy is actually decreasing as we move from the chlorine to bromine and then to the iodine. So how can we actually explain this trend, that the bond energy is actually decreasing? So what we can write is the the number of electrons, or the you can say the permanent dipole or the induced dipole, or you can say the bonds actually do not have any relationship with the bond energy. So first of all, what we can write is that the atomic size increases down the group, and the bond overlap becomes less efficient, or you can also write uh, they cannot actually hold on to each other, so less efficient. So as a result, the bond strength decreases. Now let me explain this point. Okay, let me explain this point. So for example, if this is chlorine and this is another chlorine, so you can see that these are actually small atoms. Okay, but as we progress down to the iodine and to the I2, what happens that the atoms are very bigger in the size. So for example, if these are the two I2s, this is the one iodine and this is the second iodine. Now you can see that this overlap is becoming inefficient. The bond length is actually much more than that of the chlorine, and the nucleus will find it much more challenging or difficult to keep hold on the straight pair of the electrons than in the chlorine. And the chlorine, they are much closer than in the iodine. So this is the main concept behind this, the bond length. Okay, let's move on to part B. Explain with the use of equation. So it is necessary to use the equation. How chlorine Cl2 is used in the water purification. State the role of the active species produced. So first of all, what we do is chlorine is added to water and it forms hydrogen chloride plus hydrogen chlorate. HClO, or the hydrogen chlorate, is a disinfectant and kills bacteria. So this was very easy question. This should be on your fingertips. Okay, the sodium halides in table 3.1 shows the trend in chemical properties. Identify a sodium halide that reacts with a concentrated H2SO4 to form H2S. Now this, you should remember that the only and only there is one sodium halide that can reduce, you can say, the concentrated H2SO4 to H2S, the lowest oxidation state possible for the sulfur, which is -2. So this is sodium iodide. Okay, the iodine has this much, you can say, reducing ability to reduce the H2SO4 to H2S. Identify a sodium halide that only undergoes a Bronsted-Lowry acid-base reaction with the concentrated H2SO4. It means that it will be the halogen atom that will be with the halide, with the sodium, the halide atom which will be the sodium, it will be actually above the iodine and above bromine, because bromine actually goes with the, you can say, it goes under redox reaction. It does not only undergo Bronsted-Lowry acid reaction. All of them goes into a Bronsted-Lowry acid-base reaction, and after that they go in reaction with the redox reaction. So, but the only one that only does the acid-base reaction is the sodium chloride, the chlorine. Okay, so the chloride atom, you can just simply write the chloride atom is the only one that does not have the reducing ability to reduce H2SO4. Part 3 says a student adds a few drops of silver nitrate to the solution of NaBr. State what is observed. So a cream PPT is observed. Okay. Now let's move on. So D says iodine monobromide IBr is a dark red solid that melts near the room temperature. IBr reacts with the propene. The mechanism for this reaction is the same as the mechanism for the HBr with the propene. So now They are talking about the electrophilic addition. So identify all the intermolecular forces that exist between the molecules of IBR. So for example, if this is IBR, this will be much negative, this will be much positive, and they have the electrons, and every compound has the temporary dipole forces. So IBR will have temporary dipole forces because of its electrons, and because of this difference in electronegativity it will have, and due to this difference in electronegativity, it will have permanent dipole as well. Okay, so name the mechanism involved in the reaction of IBR with the propene. So it is same with the HBr. So the name for this mechanism is electrophilic addition. Okay, so now let's move on. The reaction of IBr with the propene forms two structural isomers. Draw the structural isomers shown by these molecules. So for example, if this is the propene, okay, this is the propene. So what can actually happen is that this is the Br. Let me just draw this. So this is the propene and this is the IBr. So what can actually happen is that, first of all, according to the Markovnikov's rule, and the major product that is formed is that the iodine will actually, you can say, it will bond with that carbon which has, you can say, least number of alkyne chains, and the Br will, which is a, you can say, negative group, it will bond with which has more number of alkyl chains. So first of all, what can happen is that uh, this, you can say, bromine can attach with this and this iodine can attach with this, or alternatively what can happen that this iodine can attach with this carbon and the bromine can attach with this carbon. So we can just make these two types of the structural isomers. So let's try to draw their structural isomers. So this will be HBr, and this one will be H, then we have C, I, H, and the last carbon H, and so this will be the structure like this. And you can also like, you can say, form the, you can say, the skeletal formula of this, which will be like something like this. Okay, so this will be Br, this is one of the carbon atom, this will be the second carbon atom, and it will have this iodine group, and this one will be the third carbon atom. So, and for this one what can happen is that we can just reverse what we did for the other. This one will be the Br will and the iodine will exchange the positions. So this will be H, H, and H. This will also be H, and there will be 2H here. So it will form a structure like this: one carbon, then we have the second carbon, this is Br, and then we have a third carbon. Identify type of structural isomerism shown by the molecules in D part 3. So you can just see that the Br and the iodine are actually changing their position. So what this is called? The position isomer, or you can say the positional isomers. They are positional isomers of each other because the functional group are actually changing the positions. Explain why the two structural isomers do not form in equal amounts. Now let me tell you and just discuss this question. So there is actually an electronegativity difference, which is actually the reason for the partial negative and the partial positive charges on the iodine and the bromine. Okay, and due to these, you can say, the uh, difference in the electronegativity, what actually happens that The iodine is attracted first. It has the plus charge, uh, because of the, you can say, the electrons in the pi bond. They attract this iodine, and after that the bromine attracts the other one. So there is actually, you can say, there are more alkyl chains when the iodine attaches to that carbon which has more hydrogen. So it will actually have, you can say, the bromine attaches to the other one because it has more alkyl chains and it has more positive inductive effect. So what does positive inductive effect mean? It has the ability, so it can, you can say, type of push, or you can say neutralize the effect that is being produced by the electrons of the bromine. It is, you can say, a heavier group. Okay, so it is actually, it has the ability to, you can say, the push off, or you can say, just stabilize the electrons of the bromine. Otherwise it will just break off. So that is why it forms one of this major product, which is actually a secondary carbocation. It is more favored than the primary carbocation, in which the bromine will actually attach with the first carbon. So now we can just write this here, that due to difference in electronegativity, the iodine plus bonds with carbon with more, let me just remove this, so with more hydrogen. Just remember, it is the same as the HBr, in which the H has the positive charge and the Br has minus charge. Okay, so more hydrogen and the Br minus bonds with with carbon with more alkyl change, which has more, which has more positive inductive effect. So when the Br is actually, you can say, moving on to the second carbon, it is actually more favored because it is a secondary carbocation. So the secondary carbocation is more favored or more stable than primary, hence it is made in more amount, or it, you can say, it is a major product. You can also say it is a major product. So hope you understand this. Let's move on to, I hope it's the last question. So figure 4.1 shows the compound J to M, which each of which contains 4 carbon atoms. So they have given us that each of them contains 4 carbon atoms. So you can see that J has actually a aldehyde group, and the K has the ketonic group, the L has an OH group, and the M has a carboxylic group. So table 4.1 gives the details of the test on the J to M. In each test, only 2 compounds give a positive result. Okay, so complete figure 4.1. Observe, so they are actually adding acidified K2Cr2O7 and the observation of the positive result. So they are actually asking us what are the observation of the positive result, which one will give you the positive result. So first of all, if you have a look at the OH, it is attached to these 2 carbon atoms. It is a secondary alcohol. So this means that it can be oxidized to ketone, so L, and let's have a look at the carboxyl. So carboxylic acid do not oxidize except two of the carboxylic acid, which you will study in the A2. So this is L, and the ketone do not oxidize. The aldehyde do oxidize, and it forms the carboxylic acid. So L and J. Compound that give a positive result. So okay, actually they have given you the compound that gives the positive result. We have to write the observation of the positive result. So what will actually happen with the K2Cr2O7? It will turn from orange to green in color. Okay, alkaline I2, it gives yellow PPT, but with which compounds? First of all, let's have a look. This is a CH3, okay, and the second carbon which is to which the CH3 is connected, it has the OH group. So L will show the the triiodomethane, the triiodoform test. So now we have the aldehyde, it does not show this test, and then we have the ketone. So it is a methyl ketone. The methyl group is attached with the carbon with the ketonic group. So K will also show this L and K. Then the orange PPT, we know that orange PPT is found because of the 2,4-D in pH. So J and K. So J is the you can say the aldehyde, and K is the ketone. So it will be 2,4-DN pH. Let me just remove this 2,4-DN pH. Okay, so and with the sodium, the OH and the carboxyl group will only react. This will form the ethoxide, or you can say the this H will be replaced with the sodium. Okay, and this will form a type of, you can say, an alkali, organic alkali, and the M will be the carboxylic acid. It will react to form salt plus water. So what will be the observation? You can simply say fizzing, because the metal or the carboxylic acid reacts, they form the hydrogen, and also with the OH it also form the hydrogen. So fizzing, or you can say the effervescence, and it will be with the OH and the carboxylic acid. So it will be L and M. L and M. So this was worth of 5 marks, an easy question. Let's move on. So now in the B part, they are saying K, or the potassium reacts with the HCN in the presence of a KCN catalyst forming N. So complete figure 4.2 to show the mechanism for this reaction. So this is the reaction of a nucleophilic addition. This is the nucleophilic addition reaction, and include the charges, dipole ions, you can say the lone pairs of electrons, and the curly arrows as appropriate. So first of all, what we will do is that this is the carbon, this will have the positive charge, this oxygen will have a negative charge. So what will happen, this double bond will break heterolytically, and all of the electrons, we will show a full arrow that all of the electrons will be gained by this oxygen. So what will form, this will be this one bond will be broken. Let me just show it to you. So let me just correct this. Okay, so the oxygen will gain all the electrons, it will have a negative charge. Then we will have the C2H5. Then we will also have this we will also have this H3C, and also the cyanide group, this is negative in charge, so it will attack this carbon atom. So the cyanide group will actually be attached to it as well. Let's just draw it here. Okay, so this will be the cyanide group like this. Now what will actually happen, that uh, this is the HCN. Okay, they have given you that KCN and the HCN are actually reacting together. So what is the function of the KCN catalyst? Its function is to reform at the end. So for example, this is the HCN, this has a negative charge, this has a positive charge. So what will happen, that the lone pair with this oxygen will then attack this hydrogen, and then they will bond to form the OH group, and this CN, the CN ion will be regenerated at the end. This will be regenerated at the end. So this is the definition of a, you can say, uh, homogeneous catalyst. Okay, so identify the class of compound of which the N is a member. So N is a member of the cyanohydrins because it contains the cyano group, the which we call the nitrile group, and the OH group, and you can also call it hydroxynitrile. Okay, no problem in that. So hydroxynitrile, or you can write a more, you can say, uh, precise name, I would say. So it will be cyanohydrins. N has a chiral center. So N has a chiral center because this is a carbon and this is attached to four different carbon. You can say this carbon is attached to four different groups. One is the methyl group, one is the OH, one is the nitrile, and one is the ethyl group. So let's just um, see what they are asking. Explain what is meant by the chiral centers. So chiral center means, you can, or we can just simply write, let me just remove this. Okay, first, so we can just simply write, we can simply write carbon atom attached attached to four different groups. So this is the definition of a chiral center, the carbon atom which is attached to four different groups. So what they have the ability, they have the ability to form, you can say, mirror images in the 3D space or in the spatial arrangement. So this is the definition of the chiral center. So the paper is finished. There were four questions in this paper. We have completed the whole paper in an hour. So hope you like this video. If you found this video helpful, like, share, and subscribe the channel, and also share it with anyone you think it will benefit or help. So I'll be meeting you in another video. Till then, goodbye.